Hi, I'm Dylan Kearns, and I'm going to show how to wire in an elm-ts-interop project from start to finish. So we're going to start with a vanilla Elm project with no elm-ts-interop, and we're going to end up with type-safe ports where your flags and ports have TypeScript type information. And we're actually going to do that without TypeScript. We're going to use TypeScript to do the type checking on a vanilla JavaScript file using something called JSDoc. This is my preferred way to do it because it requires less boilerplate. It requires less complex of a pipeline where you don't need to transpile your TypeScript. You can just add annotations using JSDoc comments in your JavaScript code, and you get all the benefits of the TypeScript compiler without the boilerplate and extra heavyweight process. So today I'm going to be demoing the elm-ts-interop-pro tooling, but you can also use the community edition, which is free if you want to try it out, or if you prefer to use the free product. For this video, I'm just going to be demoing the pro version. So let's dive in. I've got a little exercise here, which, so to start, I've got an Elm Live dev server. And our goal is to take some of these input fields and buttons and values and wire them in using flags and ports. So our app looks like this. It's basically an Elm app where we're not using these flags, and we need to get this value from flags, the operating system, and get that into this string here. For sending an alert, we have this value in our model. We have the input data, but we don't have a port to send it out through. And also for scrolling to these images, we want to click it and scroll to an image, but we don't have a command wired in for that. So that's our exercise. The starting point for our JavaScript code, we just have this index.js file, and we're initting our Elm app, and that's all. We're not passing in any flags. We're not wiring in any ports yet. So first, let's install elm-ts-interop-pro. So when you sign up for Pro, you get access to the GitHub repo, which allows you to get this npm token. The instructions are sent to you when you sign up for Pro. So what we're going to do is we're going to npm install the incremental elm/elm-ts-interop-pro package. In order to do that, you just need a simple npm-rc package, just a little copy paste, and make sure the npm token is on your path. There are instructions here. I'll include a link to this file for your reference. So once you've done that, you can install the npm package. And if we look at the help, we can see some of the flags here that you can use. I just use npx here as a way to make sure that I'm using the locally installed version in the dev dependencies of this project. So now our goal, if we look at our index.js file and we look at elm.main.init, it's any, which is basically TypeScript's way of saying, I'm not going to help you out here. Well, we want it to help us out. That's our goal. So if we say elm, app dot, it doesn't give us any IntelliSense. If I pass strange data to the flags, then it's fine with that because it doesn't know anything about our Elm application's types. So that's our goal, is to bridge that gap so that JavaScript and the TypeScript compiler know about our Elm app's types for our ports and flags. So that's where elm-ts-interop comes in. So we're going to use elm-ts-interop to generate a TypeScript declaration file. A TypeScript declaration file is a lot like a C++.h header file. It just gives type information to TypeScript. And it gives that type information based on a definitions file. So what we're going to do is we're going to run elm-ts-interop-pro. I like to specify a gen directory. I like to output my generated code to gen. And we're going to output the TypeScript declaration file to source main index.d.ts. What happens is if you're using something like Webpack or Parcel or a tool that allows you to, import Elm from source/main, then it's actually automatically going to pick up the types. We're just using vanilla JavaScript setup with Elm Live, so that's not going to happen in our case, but it's just a convention that seems to work pretty well in general. So we're going to need a definitions file that elm-ts-interop can use. So I'm going to just create source/definitions.elm. And just to make a valid module, let's do a little hello here. Okay, now let's run this command. And if we look at our version control now, we've installed this package. We created this definitions file. And we've got a couple of generated files that came from running that command. So we've got this index.d.ts. And notice that the data that can come from Elm, there's a tag hello with data null, which is just what we specified here. If we change this to goodbye and rerun it, then that's going to update. So this is how we pass that type information from Elm to TypeScript. Let's change the type of our flags. Let's just set flags to be a Boolean. So flags is a special value. The exposed value flags here, if I expose a decoder called flags, let's just have it be a bool value. Rerun this. Now the type of our flags is Boolean. But it's not complaining yet. It's perfectly fine with null. So that's where we have to take that type information and import it. If you were using something like Webpack, as I mentioned earlier, the way you imported it, it would automatically pick up that type information. But since we're just using this sort of global namespace Elm in our index.html, this is what it looks like. TypeScript doesn't know anything about what's available in the global namespace here, so we have to give it a little hint. So I'm just going to include this little reference path that's telling TypeScript, hey, pull in this type information here from this file. So now, if I hover over init, notice that the type of flags, we have type information now. In fact, if we say app dot, look at that, IntelliSense, app.ports dot, and it knows about some of the values that we can send and receive. But notice that it's not complaining about our flags being null. So let's go to our tsconfig.json. This is a common thing that I think people may miss when they're setting up their TypeScript projects with JavaScript. Don't forget to enable check.js. If you enable check.js, then that's going to finally wire through that error. So now it's telling us those aren't valid flags, but if I give it a Boolean, it's valid. I'm getting kind of tired of rerunning this elm-ts-interop-pro command every time. So let's just set it up to do a watcher with Chakadar. So anytime we change our Elm source code going forward, it's automatically going to rerun it to keep that index.t.ts TypeScript declarations file in sync. So going back to our main.elm module, we've got this TypeScript type information telling our TypeScript code, or our JavaScript code here, that it expects flags to be a Boolean type. But how do we get that information to elm-ts-interop? Well, we need to do a little bit of initial wiring to get the ports wired through. The way we do that, if we look at our git diff again here. So we've got our index.d.ts file that's generated. We've created this definitions module. And we also have this generated file, interop ports. This is actually generating some ports, and it gives us a function called decode flags. So that's what we're going to use here. So for our flags, we're going to say interop ports.decode flags. Now, TypeScript is not a perfect type system, so we can fool the TypeScript type system. So I recommend explicitly checking for errors and handling those. We're going to do it quick and dirty here and just do a debug.todo, but of course you can handle that however you want, depending on whether you're in dev mode or production mode. You could send something to a bug tracker or however you want to handle that. Okay, so now that we're debugging these flags, we're going to need to import this, of course. Everything is compiling. And now we're decoding these flags. Let's just go ahead and log this here. Okay, so we've got our flags being decoded correctly. But now here's the fun part. We want to actually use those flags to do something interesting beyond just getting a Boolean. But before we do that, I want to make sure that we've got a clean slate here with our commit history. So first of all, we added allow.js and check.js. Let's commit that. We've wired in our flags, and we can go ahead and remove this debug log statement. Now, I don't want to commit this generated code. I don't want to commit the generated interop ports.elm module. I don't want to commit the generated type definitions. The reason for that is I want to make sure that it's not using a stale version of this. For example, in my CI server, I want to make sure that it needs to actually generate this so that it's always fresh. So let's go ahead and add this to our gitignore. So we're going to gitignore the gen folder, and we're going to gitignore index.d.ts. If you wanted to, you could ignore all index.d.ts files. It's sort of personal preference. I'm just going to ignore this specific file. And then we wired in our reference path so that it gets the TypeScript type information for that, and wired in the flags. Okay, so I'll go ahead and commit this. Step 1. Now for the fun part. Let's do something a little bit more interesting with the flags. So we want to know whether we're running on Windows, Mac, or Linux. So we want to fill in these question marks here. And in order to get that information, we want to pass it in a flag. But right now we're just sending this Boolean. So let's try decoding it. The cool thing about elm-ts-interop is that whenever you change your decoders, it's always in sync. So let's decode some literal strings. So I expect it to be a literal value that's either Mac, Windows, or Linux. Let's just start with Mac. And this literal value needs to be a JSON encode value. It can be any JSON encode value. In this case, it's just going to be a string. And remember, we've got our Chakadar process watching for changes in our Elm source code and automatically regenerating our index.d.ts. Ah, yes, and I forgot to create this generate pro task. So let's take this command we were running, add it to our package.json scripts. I'll just call it generate TsInterop. We don't need to use npx here because it's in a package.json script. So let's actually run our Chakadar here. Okay, so the type of our flags is Mac. Let's just leave this open on the side here. So type of flags is Mac. Let's go ahead and add Windows. So the OS could be Windows, but that's just my Elm type. My Elm type could be Mac or Windows, but there's actually no way that this decoder is going to yield the value Windows. So let's add a one of for Windows. And there we go. It's a union type that's either Mac or Windows. So these are a really cool feature of TypeScript. It's called a literal type, and it's just the literal string Mac or Windows. Let's see how that feels in our index.js file. So, well, we've got this error here now, and it is correctly telling us that true is not a valid value of type Mac or Windows. And notice that we get this cool auto-completion where it knows what the valid values are. Once we fix that, the error goes away. And let's look at our main.elm. So now our OK flags, if we look at the value of our OK flags, it is an OK OS value. Let's just do debug.toString for now with our OK flags. You're on macOS. Cool. Now what I really want to do is I want to get the OS name the proper way. And I've got this little helper function here. It's not perfect, but it's all right. And notice that TypeScript, even though this is just a plain old JavaScript file, we've set our tsconfig to check JavaScript. And so it has this type information. So it knows that this function is going to return this type. So if I can get my cursor over here, let me just copy this type. Now notice if I were to say get OS name here, it says, wait a minute, that type is not assignable to this other one because it has these extra values, Linux or null, that I'm not decoding, right? So my decoder would fail. So elm-ts-interop is correctly pointing out that this decoder will not handle those values. So I'm possibly going to have a failing decoder. So elm-ts-interop prevents that. Now, elm-ts-interop-pro has an online generator tool. So let's use the online generator, and I'm going to paste in this type, and I'm just going to export type OS equals. And here we go. We've got this encoder and decoder. We just want to use the decoder. This is what the encoder would look like if we wanted that. So I'm just going to copy the OS decoder and the type that it generates for me. I'll just paste it into my definitions file. I should probably change the scaffolding tool to use ts dot in front. It's kind of a good convention. Okay, and I've got OS defined twice because it generated the same type. And notice that it's nullable. It detected that it has or null in this union here, and so it made it a nullable decoder. And we've got our Chakadar task watching here. Now notice that we've got our toElm. It's got this OS decoder. We didn't really want that. So the reason it's doing that is because everything we expose in our definitions.elm is going to be turned into a flag for us. So what we really want is we want to not expose the OS decoder value. So let's just explicitly expose flags and goodbye. Okay. So now we no longer have that OS decoder value as one of the ports that we can send from Elm to TypeScript. And our flags are correct. Now let's go back to our index.js. And now our getOsName is sending only values that can be handled in our decoder. And so it checks out on both ends. Now the really cool thing is the source of truth is the decoder itself. And so that keeps both the Elm types and the TypeScript types in sync. So let's say that we had other values we were going to send in our flags here. You know, this isn't so ideal to just send in this value as the flags directly. Usually you want to send it in as an object, so you can send multiple values. So let's do that. So for our OS decoder, let's just do just like a regular decoder, except we're going to use TsDecode.field. And let's decode it as a field called OS. Now our flags are telling us you're sending an invalid type here. And if we pass this in under an object, notice we even get this cool type completion where it says, oh, maybe you want to pass this in under OS. Now it checks out again. Now notice this is kind of interesting. We just decoded it under a field, but we didn't decode it into a record with a field. So this is still compiling on the Elm side. Well, it's compiling because we're just kind of directly pulling out these flags, but the type hasn't changed. It's a maybe OS. It's not a record. So this is one of the cool things about elm-ts-interop is that it decouples the types that you're using in TypeScript that you're decoding from or encoding to, and the types in Elm that you're encoding from or decoding to. So let's just give this a type annotation to make this explicit. This is a TsJSON decoder, tsjson.decode.decoder, and it decodes to this Elm type. Let's change this. Let's decode it to a record. Let's just have a record called flags. Okay, so we've got our flags record, and we want to decode into that. So we say it's a decoder of flags. And of course, it's not yet. So we can just say map it to flags. And of course, by doing that, we've changed the type we end up with here. If we were actually doing this properly, we would get an error because we would be doing OS2string or maybe OS2string, and the types wouldn't line up anymore. So that's the really cool thing about elm-ts-interop is the types always line up. All you have to do is you change your decoders and encoders, and the types stay in sync. So the source of truth is not one side or the other. It's not TypeScript, it's not Elm. The source of truth is the decoder or encoder, which translates between those two types. So they're always in sync. Now let's wire up a port from Elm to our JavaScript code. So in our main.elm, we've got this update function, which has send alert. And what we want to do is we want to send an alert message here. So we're going to need a port. So how do we define a port from Elm to TypeScript or JavaScript? Well, we just define a top-level value, and since it's going from Elm to JavaScript, it needs to be an encoder. And we're just going to encode the payload. So TsDecode.string. So what does that do? Well, we've got our Chakadar task, so it automatically reran when we changed our code. Now, if I look at interop ports, yes, and I need to expose alert. So let's expose this. So now when I look at interop ports, we've got an alert function here. And what's the type of the alert function? It's a string to command, which is exactly what we need. So we can just take model.input, send it through our alert. Let's try it out. And it's not doing anything yet because we haven't wired in our ports. Now the question is, do we have IntelliSense? So let's look at app.ports.interop from Elm. We already had that. We can subscribe. We've got a FromElm payload. And what does that payload look like? Well, it's elm.fromElm. And well, if we go in here and look at that, we've got our new alert type with a payload of string. So how do we handle that? Well, we can just do a switch statement, which is going to be familiar. It feels a lot like using the Elm update function. So we switch on tag. So each of these top-level values has a tag that matches the top-level value. So case, notice we've got this IntelliSense, and if it's alert, then what do we want to do? We want to send an alert. Alert with what? With our payload from elm.data. That's just a direct payload. It's not under any fields. So we can just alert like that. Now let's try. And it's wired in. Awesome. Finally, let's wire in these scroll to photo helpers. So we could do this with vanilla HTML, changing the location in the URL, but we're going to use the browser scroll into view helper to find these elements. So what I want here is I want to use something that is a built-in DOM type that is defined in TypeScript. So I'm going to go ahead and use this scaffolding tool again. This is a pro feature that's included. And so I just did export type and I gave it a name and I'm exporting a built-in type. So notice this little helper here. This is like a fully functional TypeScript playground. Of course, that's valid TypeScript because why not? Because TypeScript is JavaScript. But it's going to give us IntelliSense and error messages, and it's going to infer those types and generate code for us. So let's just grab this generated code. I'm going to paste it in. And I'm going to call it scroll into view. Get my imports. I don't want the decoder, so I'll just delete that. And let's rename these types. And because it's in a module called scroll into view, let's just call this encoder. Okay, so we've generated all of this, and we've generated it from this existing TypeScript type, which is nice because then we have that confidence that we can use that built-in API and the types are going to line up. So let's just wire that into our definitions. So we want to say scroll into view, and we're going to say scroll into view encoder. And let's be sure to expose this. And now, when we go to our index.js, there's a new case we can handle, scroll into view. So we can say document.getElementById, but which element? We're actually going to need the ID. So let's add some additional information. So we don't directly just want to use the scroll into view. These are sort of the scroll into view options. We want to say TsEncode object. And we want to take the options and encode those as options. And we also want to pass along an ID to scroll to. And we'll get that from ID on the record. And this is just going to be a TsEncode string. Just going to encode a string there. So now it's syncing in the background. We can just do FromElm.data and let's see what we've got. And there we go. We've got an ID. And now when we say scroll into view, it needs scroll into view options, which is just what we generated the encoder for. So let's grab our payload. And notice that the types line up. Cool. And notice, so this is what TypeScript knows about the data we're passing in. How does it know that? Because our TsJSON decoder and encoder here. Pretty cool. Let's try it out. Ah, yes. And of course, don't forget, we do have to wire it in main.elm. Not quite that fancy. So we're going to need to use interop ports dot scroll into view. And what does it take? Well, we're grabbing ID, which is going to be this ID, and we're going to need to pass in the options. And those are going to be scroll into view options, which looks like this. Get that compiling, we'll just use all the default options there. And there we go, we're scrolling. So this is cool because now we've got this kind of general purpose API that if we want to, we can pass these values in. So let's try smooth scrolling. Not my favorite, but hey, the types line up, that's cool. So I'm just going to go ahead and explicitly use auto scrolling. So that's it for the demo. We've wired up our ports and flags. We've got our working app. We've got a point to iterate and keep our data in sync. And if you want to try this out, you can go to the elm-ts-interop starter repo. I'll add a nice README to give a little more information. But I've included this as an exercise branch. So if you want to try it for yourself to get some practice, you can try out that exercise for yourself. Hope you enjoyed. Thanks for watching.